So I'm going to go over what Solid is as a project, but I'm going to start off with a little bit of a history of the existing web and where we're at the moment, and how Solid can be applied to create the next generation of web applications as an essential augmentation to microservice architecture. I'm going to rush through these slides because I probably have well more than an hour's worth of slides. So if I go over anything too quickly, then please let me know in DM, and I can go and have another conversation with people in Slack as well. So understanding major influences and efforts, understand fundamentals of the decentralized web, and I'll explain what that is later. Foundation for further exploration into the next web. Grasp of when and how to apply decentralized web technology, obviously for commercial viability. Defining a platform. We obviously live in the platform ecosystem right now, so what is a platform? I try to keep this as close to how we define it technically as possible. So a platform is a basic technology of computer systems, hardware and software, defining how a computer is operated and determining what other kinds of software can be used. So platforms like Windows and Google Chromium, etc. The web is not a platform by this definition. It's based on standards, not technology. Maybe Chrome is a platform. Internet Explorer is a platform, not the web. So an ecosystem definition is a community of living organisms in conjunction with non-living components of their environments. So I think this more fits in with how we look at the web at the moment. There's different APIs that we connect together. So this is what I hear all the time. Privacy is dead, and also privacy isn't really marketable. Correction, for me, privacy is playing possum. It's the idea that privacy isn't dead. Privacy is just pretending to be dead because people are giving up on it at the moment. It's actually a spectrum. We give up on privacy all the time in conversation. Every time we have a conversation with somebody, we give up a little bit of privacy. If you say, yesterday I stubbed my toe, you're giving information to somebody that you stubbed your toe yesterday. Just giving up your information is always an element of giving up on privacy. It doesn't mean necessarily that you're giving up on everything. We always have control over every bit of information we have and how to actually share it. So at the moment we have a generation that's willfully giving up into centralized services for actual benefits like free email, cheap taxes and birthday reminders. We're giving information to Google, Facebook and Uber for those things, and really it's providing us with very few benefits apart from some free software. So we can take it back and we can build commercially viable systems whilst we do this. So building commercial systems, we can do privacy first capitalism solutions. So the idea that we protect people's privacy and we build marketable solutions at the same time. And you can do this within commercial environments with banking solutions, regulatory systems, retail systems. You can build commercially viable systems that use a privacy-first model. And it is becoming quite fashionable to do so at the moment. So companies like Apple and Mozilla market themselves on doing this. Even if they don't do it 100%, they do use it as a marketing strategy. And legislature like GDPR means that we have to actually look at privacy as a first solution into system development. It doesn't mean we don't give up on data either. So the first version of the web, and I'll try and rush through this quickly, we had Mosaic in the beginning. We had Netscape, which licensed the Mosaic browser engine and built the Netscape company, originally called Mosaic. And they built a new browser codenamed Mozilla. And then they tried to do a lot of proprietary stuff as the first browser on the market, like JavaScript style sheets instead of CSS. So CSS became standardized. Netscape or Mozilla thought that JavaScript style sheets were much better, which probably sounds familiar to a lot of people. But they lost out to standards. CSS won out. Internet Explorer came along, and Internet Explorer built a much better browser than Netscape because they didn't make it commercial, they made it free, and they worked with standards. And Internet Explorer therefore gained the market share, understood that people wanted a free browser, wanted standards compliance, and wanted developers to be able to develop apps quite quickly. So they ended up building a better user experience for the web, and Netscape started becoming buggy and falling behind. Then Microsoft got confident, they gained market share, they built a very popular browser that had 98% market share at some point because they had Windows and it packaged in there, and they developed their own way of developing communication with server-side apps called XML HTTP request in 1999. Then Mozilla tried to implement their own version, and it kind of fragmented the marketplace for developing apps that could communicate with server apps, and jQuery came along to actually fill that void so developers could build one set of APIs that could communicate with server apps on any browser. We don't need jQuery anymore because people are actually applying standards compliance communication methodologies. And then Chrome came along, forked WebKit, built Chromium, now has 63.13% market share on all devices, including mobile, not including iOS because they don't use their own rendering engine, and then did the same thing as Internet Explorer. They're now going proprietary. They developed systems like Gears and Google Knowledge Graph as well, which kind of aggregates everyone's data and tries to share it, which ends up creating a fragmentation of search engine results. If you go into search engines now and you search for something, you'll see a knowledge graph appear as well a lot of the time. But that knowledge graph means you get the information before you go to that website, which means that website never gets that conversion. It never gets that traffic. So Chromium is now kind of, with Google, creating a fragmented ecosystem again, but it benefits developers. We have a great set of developer tools, so why use anything else? So that's the current web. Web 2.0, which came out in about 2001, but hardly anybody's using it, applies some semantics to the web. So we have RDF. RDF is used for connecting different resources and actually creating a semantic meaning to resources. So we can understand what an address is, we can understand what a name is, we can understand a location, and it supports micro formats. So anybody that's used to using attributes within HTML tags and use micro formats, that's the basis of RDF as well. It's supported by IBM, Microsoft, Reuters, Nokia at some point, Netscape before it was Mozilla. So it's got quite a lot of good support within the standard, but it's still used primarily within organization-to-organization communication, not within web applications in itself, which is a little bit of a missed opportunity. And then we have OWL, because it's good to start naming things after animals. OWL uses ontology for the web, so the idea that you can provide classification within web artifacts. So what is an address, what is a name, what is a photo? You start classifying different bits of information, which gives you more meaningful information, which is perfect for building your networks from. If you imagine every website has OWL capability within it, because it's a standard and all browsers support it, that means that if you're building a artificial intelligent machine learning model that wants to gather loads of information, you have an entire global database available within the web to pick up information, classify it, use it in a model, and train a model with it. Again, a missed opportunity at the moment. It's used, we're just not using it enough. And then we have Turtle, which is a more recent technology in 2011. Turtle enables us to restructure that data a little bit better in multiple languages, so we can create meaningful information in web pages in multiple languages and serialize that information as well. And then we have SPARQL. And SPARQL is great technology for querying web pages. So now you can actually look at all of this information, all this relational information and semantics, and we can provide a query language on top of it, built into the web again. It's existed for quite a few years, and SPARQL can provide us a method of using SQL-like syntax to query web pages. And this is what Google uses as well for their knowledge graph. So it's useful at the moment. All the billions of web pages that exist all support SPARQL, so you can, as long as you're providing an RDF methodology for semantically tagging your data, you can now query any web page as well. Again, great for building AI applications that want to query multiple web pages. And all of this has existed for quite a few years. And then we have linked data in 2006. The group came up with linked data, the idea that you can connect any web page to any other web page as a resource by using the URI of that web page. And then you can combine RDF and SPARQL then to start essentially creating a relational database system out of the web. So it's a global database we already have access to now, and we just need to use it in a meaningful way. So Tim Berners-Lee summarized linked data with 3 simple rules at a TED Talk in 2009. All kinds of conceptual things, they have names that start with HTTP. What it means is we have an ID. A URI is now the ID of a resource. If you take one of those names and look it up, you get meaningful information back. You get semantic information that can be used. You can find the ontology of that information, the meaningful parts. And then when you get that back, you can see the relation of that object to all other objects. So your ID could be matched with somebody else's ID, and suddenly you are related to somebody in some meaningful way, whether you're a colleague, whether you're a relative, whether you're a friend. You can actually connect those, and it can be done in inanimate objects like parts manufacturing for cars, which it actually is used for at the moment. And then we have JSON-LD, which is linked data in JSON, and this actually exists in quite a lot of web pages now. I think it's 3 million web pages use this. It can be done after loading the web page as well. So the client code can load JSON-LD into it, and Google will read that after processing. But it's better to do it on the server side for a variety of different reasons. And it's also used as a main basis for ActivityPub and Activity Streams, which is a Mastodon, this decentralized social network at the moment that is trying to take on Twitter. It's used for search engine optimization, so it does matter. Using JSON-LD will create better results for you in search engines. And now we have Web 3.0. So this is what we're trying to do with Solid at the moment, create a distributed, decentralized, and federated web. So we connect disparate systems and we remove the decentralized databases. So we start off with the semantic apps that have existed since 2001. We supercharge them. So semantic apps exist at the moment in commercial environments and parts management systems for automotive industries. Volkswagen's been using it since 2001. Automotive repair and diagnostics, Renault's been using it to interchange information, again, since 2001. Knowledge management in the oil industry, so Axio's been using it, again, since 2001. So none of this is new. Food and Agriculture Organization of the United Nations, or FAO, have been using it for a long, long time. Insurance contract broking has been using it, like Lloyd's have been using it. So it's commercially viable, commercially used to actually connect different bits of information from disparate systems. If you think of microservice APIs, it's very similar, but you provide semantics over the top of it, and the capabilities are already there within web pages. And it doesn't need to be visual either. So the web was designed to be decentralized. We're just doing a bad job of it at the moment. We're losing control of things like DNS. Projects like that project, if nobody's heard of it, it's a protocol layer project to replace HTTP to create a peer-to-peer network of communication between web pages. That exists, but it's struggling with the DNS method, and it's struggling with being easy to access. At the moment, you have to be a developer really to get anything out of it. And distributed DNS is here, but it requires cryptocurrencies and blockchains because you need to provide some monetization in that model at the moment to make it worthwhile. And surveillance capitalists like Google and Facebook are actually acquiring infrastructure. So they're buying mobile networks, so Google Fi, for example, broadband networks, and DNS connectivity to actually control your traffic as well as the end user experience in the browsers. So it's a little bit hard right now to move away from that, and it doesn't make much marketing sense for the most part, but we can build on the existing technologies that provides us with the flexibility to move away. So we do have alternatives that are commercially viable. So decentralization offers commercial and competitive benefits too. Reduce cost to competitive landscape, imagining the more distributed systems that share the same language, the same ontology, the reduced cost in using those services as well. So it actually does provide a commercial benefit. Improve resilience on scalable networks. If you have high throughput networks, a lot of traffic, then creating decentralized networks reduces that traffic load as well. And if you don't need to charge for that traffic, it doesn't really matter. And the network effect. The more nodes on the network, the more master nodes, the more people are likely to be on the network. You could take an agricultural product that I developed a few years ago where the farmers all put their product onto the distributed web. They had their own version of their data. They put it onto distributed web technology. Then all the importers went on and started buying that product. And the more farmers were on that system, the more importers are on that system, and so on and so forth. So the network effect provides a huge benefit for decentralization. If you don't control the market you're in, but you want to be competitive, decentralization is much better than trying to take on the big boys. And being technology agnostic, decentralization means you can build this stack in any technology you want. You don't have to use any particular stack. Most of the capabilities are very rich in Node.js and JavaScript, but you can pretty much use any technology and get where you want to with it. And there's a reduced risk by spreading across master nodes. Again, if you want to be competitive, sometimes you don't want to take on the risk of actually being the only person in the marketplace. So find partners and build systems with it. And I'll go through some case studies of that later. So there's easier buy-in from third parties because of the reduced risk. I'll quickly go through what that is, the protocol layer for replacing HTTP for peer-to-peer communications on web. It has a few shortcomings, but apps can actually operate offline or with poor connections at the moment, and you can actually load a web app on your phone and allow other people to connect and browse. Data can be retained on an original machine, so you can carry the data around in your pocket if you want, and people can get an offline version of that data when you're next online. which means nobody's taking control of your data. It can operate on mobile devices and home computers, so you can build it on anything. It retains history like Git, so collaborative document editing, for example, can be done with that quite effectively. Discovery is weak. At the moment, the DNS is awful. It's actually centralized, even though it tries to be decentralized. And web addresses are essentially a combination of characters and numbers. So it's like having a complicated phone number. And it requires a custom browser at the moment. Beaker browser is the best one. Firefox has said they are going to implement that, but it's going to take some time. So it requires some additional effort for development. It's not there yet, but that has some promising capabilities. So many-to-many systems. At the moment, when we develop API platforms, we go many-to-one or one-to-many or one-to-one. We don't develop a many-to-many architecture. So when you want to get information about a certain subject, you always have to go to one API provider for that information. So decentralization requires that apps and data services are interoperable with many-to-many relationships, and this gives us a lot of power in building new services. We support interoperability between apps and data. These are two separate things, and I'll cover that quickly in a bit. And we can move away from the idea of centralized and sequential data gathering. When you do a web service call at the moment, you sequentially gather data. This allows us to move away from that sequential data gathering, and we can use querying for that. Rigidity leaves control with the API providers, and again, if you're controlling the market, that's great. If you're not controlling the market, then you're losing out to a bigger player. So it creates an ecosystem over a platform. And the platform ecosystem is permissioned innovation model, which means somebody has to give you permission to get their information. They're the gatekeepers, essentially, which stagnates innovation. It also means your app can only work to their APIs. If you want to do something really clever, you still have to work sequentially through their APIs, which stagnates what you want to do with that service. Linked data, RDF, and decentralization decouples app logic from data. Data and apps are not the same thing. So data services can be entirely separate to the apps that are built on them, and apps tend to be very client-based, and they're all about the UX, not about anything else. And then you can layer compatibility with that as well, so you can add different layers of information to these systems. And then distribution. So distributed applications, or dApps, which are commonly used on blockchain and in cryptocurrency, they're not required for developing dApps, but dApps are extremely powerful in other cases, so if you want to move away from blockchain solutions. We don't need DLT or blockchain at all. We can actually do it with the existing web with a lower level of complexity. So blockchain requires a high level of technical competence. We can use just basic web technology, so every web developer should be capable of building a dApp quite easily. Data can be retained with the owners rather than sacrificed, so you don't need to give it away. When you do give up your data, somebody could store that, obviously, but the single point of truth is always with you, so they'll have an outdated data set. It's modular and microarchitecture switched on, so it's microservices, but on caffeine. Apps can be built in any language, and it doesn't need to have a UI, so your app could be functional without a UI, it could build bots or anything else. And improve resilience on scalable networks. Again, high throughput makes it a lot easier. And the network effect, more nodes, more traffic, more data, everybody benefits. Distributed applications are becoming increasingly common at the moment. There are quite a few in the commercial space, so there's alternatives to Google Suite, for example, that are entirely distributed. Mastodon and Matrix provide alternatives to Twitter and Slack. Fairly good. The UI requires a little bit of work. Hearth provides an alternative to Dropbox. And there are thousands of use cases that are getting more sophisticated every day. So there are alternatives, and Federation allows us to group these together. So going through the point I'm making, which is a solid working group, which is Tim Berners-Lee created it with MIT last year, and I've been working as the chair on this group for a while, trying to build up the standards for this and make it more usable, but there are use cases in the commercial space already in this. And it uses all the existing technologies that I've already talked about. So it's nothing new, it's just about federating them together and building apps. And it's focused on apps, data, and people. So how do we develop modern distributed apps? We decentralize the developer experience, use any tools you want, build it the way you want, host it anywhere you want. It's basic web technology. Decoupling apps and data, they are not the same thing. Data, you can think of microservices. They're contained in whatever way you want, encrypted in whatever way you want, stored on whatever data model you want. And apps are the UI or the interface for this, so we can build in whatever technology. If you want to use React, use React. We're building ecosystems, not platforms. We're decentralizing. We're not trying to build a brand here. And it has universality and innovation, so people can build whatever they want, and they have the freedom to use whatever methodologies to get there. So we're building on existing standards, rich tooling, and we're browser ready, and we have been browser ready for about a decade. We're just waiting for developers. WebID provides URL-based identity for every system. For example, that's an example of an identity. That's not where my identity is. OpenID Connect can now be used with WebID, so you can have a decentralized single sign-on for all your services on the web. You don't have to use Google sign-in or Facebook sign-in. You can use one single sign-in that you own. JSON-LD is used, which we've discussed. RDS used, which we've discussed. SPARQL's used, which we've discussed. Turtle's used. These are all existing standards, and Solid is just a matter of bringing those together to create a better app development experience for the web. So Ruben Verber, who's also on the group with me at the moment, he said Solid is about choice. The Solid ecosystem enables people to pick the apps they need while storing the data wherever they want. People control their data and share it with the apps and people they choose. It's all about freedom for the end user, but it's also organizationally freedom as well to enter a marketplace where you would otherwise drown because you're a small player. People choose where to store their data, and a simple blog post, I'll quickly go through this. You can store the author's name, profile picture, and in the author's personal data pod. Company's opinions can be in the company's data pod. Discussed article title and photo in the news company's data pod, and all the likes can be on the individual people who have liked it on their individual data pod. So everybody retains their data on a single news article. And we give access the way we want. So permission data allows us to give access to Google or Facebook if we want to. But we give them access at the time we want them to, and only the data we want to share at that time. And we can disconnect them at any point. And competitive marketplaces, it provides a better competitive ecosystem. So if loads of people are doing social information, for example, then the cost of entry into that space is better, and you can actually have freedom to migrate your data to wherever you want. It provides a much better risk management method for entering new marketplaces and domains. And your data is never up for sale. And people sell their organs when desperate enough. This is my philosophy. Selling a service of personal data is offering an unethical choice to the consumer. You're always going to go for the cheapest option. Doesn't mean it's ethical. And making people give up their data for a freebie is not necessarily ethical. Apps and pods are separate. Again, we'll go through all these. Separate apps and data pods enable a competitive and scalable landscape. These are in existence at the moment. Companies are making a lot of money from these, including some of the big players. Google Knowledge Graph, for example, specifically does use this technology at the moment to gather loads of data, so there's no reason why anybody else can't do the same. Apps can be hosted by anyone. Data pods can be hosted by anybody and stored in whatever method you want. Data storage can be stored ethically where you want. You can store it in any location. You can use any encryption method. You can apply it anywhere you want, and we can get away from legislative requirements because individuals can actually control where their data is stored. It's application agnostic and technology agnostic, so anybody can build a data pod at the moment and provide a service for that. Data pods at the moment include storing things like profiles, photos, anything social-based, medical information as well. So if you want peer-to-peer medical information, data pods can be used for that. Apps are the same. You can do social networks. I'll just quickly go through this. And it's all about permission-based. So people give you permission to look at their data. So your friends, for example, on social networks, and you give them permission. When it comes to commercial systems, you could do it on insurance and medical information, give up whatever data you want. So if you want to get insured and your insurance company asks for your medical history, you can give them a snapshot at that particular point. And then these are existing apps that exist within Solid at the moment: calendars, social feeds, photo sharing, conference organization systems, banking and financial systems, mobility as a service systems, are all decentralized capabilities within Solid. So the developer experience is what's important to Solid at the moment. We need developers on board. We have some of the best web developers in the world who originally worked on Web 2.0 and worked on web payments and a variety of other technologies like WebID, but we're trying to get more developers building actual apps with this. So we need good tooling for that, and we already have it at the moment. We have tooling capable in React, Vue, and Angular, and it's not new tooling. No one's come along and said, I'm going to build these technologies, a library for these technologies and these frameworks. These frameworks always had this capability because they're modern technologies. These standards have been available since 2001. So you can actually use React, Vue, or Angular, or any other framework you want to build decentralized web applications. And this is one project I've worked on, which is about open sourcing the developer stack to make it a lot easier. And this is Part of the work I'm doing with Solid at the moment is building reference implementations in different languages and open sourcing them. So the reference implementations I have include data pods for e-commerce, social, and agriculture, and these are actually used commercially. They're not just use cases. And we control probably about 1% of one of these markets as well in terms of throughput. And decoupled apps use web components, so we're not using React, Vue, or Angular. We use standard web components for our apps. Passwordless web ID using WebAuthn. So the idea to actually just log into a system without using any password is currently possible. And it's cloud agnostic, so all the technology works across AWS, Azure, DigitalOcean, GCP, and there's even Raspberry Pi examples using serverless architecture. So it's very easy to get up and running with these tools. Single-click deployments, so we don't want to remove the technical barrier at the moment. And it's currently used in AI companies, medical companies, finance, agriculture, and retail industries commercially. So it's quite viable. And this is my first decentralized web app, which I built last year. I designed and built it as PWA, fully offline capable, installs on Android devices and on Windows at the moment, and provides a full social experience connecting to any social network that applies these standards. So you can use this one app, store your data with any third-party provider that has a social network capability, and this app will work perfectly fine with them, including Mastodon. It's Mastodon compliant and any other ActivityPub or Activity Streams compliance. Thank you.